Okay, here we go. Algebra 2, 1.4, rewriting equations. All right, so I think everybody should be pretty comfortable at this point solving equations, right? And oftentimes, like here, where we solve for y. All right, so we just go through the motions here, right? If I want to get this y by itself, I need to subtract 8x's here. And if I do it on one side of the equal sign, I have to do it to the other side. I always like to write this off to the side to remind myself I cannot combine these. These are not like terms. So we just drop down this negative 2y. We should always write the variable first. So let's just kind of switch the order here. This is a positive 18, so we'll put plus 18, and we'll divide by negative 2 on everything. All right, and we're left with 1y is equal to negative 8 divided by negative 2 is 4, and 18 divided by negative 2 is negative 9. And there we go. All right, let's see if there's some more things we got to do, like in this next problem here. Go to a smaller ink here. All right, so if I want to solve for y, right, I'm going to isolate this. That means that everything except for this negative 5y I need to get rid of, okay? So I want to subtract 3x and subtract 11, okay? And I can do that as long as I do it on this side as well, okay? So I'm just going to kind of update this problem. Negative 5y is equal to negative 3x minus 11. And now, once I have y all by itself on one side, now I want to get it equal to a positive 1y. So I divide by the coefficient in front of y. In this case, it's negative 5, so I divide by the same thing, negative 5. And I'm left with positive 1y is equal to this. We can keep this as a fraction, but we have a negative over a negative. So this is a positive 3/5 x. And we have negative over a negative, so this is a positive 11/5. You could convert that to 2 and 1/5 if you wanted to, but an improper fraction is fine there as well. All right, let's just do a couple more, just get in the swing of things here. So again, I want to isolate this negative 3y, so I got to get rid of this x. And I'm left with negative 3y is equal to negative x plus 14. Now I want to divide by negative 3. Got to divide everything by negative 3. So we're left with positive y, 1y is equal to, this I would think about this as a negative 1x divided by negative 3. So how I would write this is negative over negative, call this a positive 1/3, and then put the x right next to it. All right, and again, we can certainly leave this as an improper fraction. That's fine. It's going to be negative because we got positive divided by a negative. So it's going to be negative 14 over 3. Or you could convert that to a mixed number and call that negative 4 2/3. Either one is fine. All right, next one here. So here we've got it. We're solved for x here. So if I want to solve for y, I can just I can do this in two ways, all right? And it's really, a lot of times because y is equal to mx plus b, we've all heard that equation, right? This is the equation of a line in slope-intercept form. So the y is on the left side, but if I want to solve for y, the easiest thing to do would just be to keep the y on this side, subtract this 7 on both sides, and I'm left with x minus 7 is equal to negative 2y. And now I can divide by negative 2, divide by negative 2, divide by negative 2, and I'm left with y is equal to negative over negative, that's positive 7 over 2, and I'm going to call this negative 1/2 x. All right, now is this the same thing as this? Yeah, just a different way to write it. I just got to this answer a little bit quicker, keeping it on the right side, and then in the end I flipped it back where y was on the right side. All right, so basically what we're getting into with this lesson is manipulating equations any way we want. We can solve for any of these variables if we want to. We're just doing the inverse operations. All right, we're doing inverse operation in reverse GEMDAS order, right? If we were to be solving these equations out, we would follow GEMDAS, and to solve, we would work this way, okay? But if we're going to be undoing them, we're going to work backwards, okay? So let's see here. Let's just take an example here. Number 5, we've got the area of a triangle. So all we need to do here, we're isolating B. All right, so first thing I want to do is I want to get rid of this H. Okay, and I can get rid of this H because this is 1/2 times B times H. So if I want to get rid of this H, I just divide it, and now that's equal to 1. Okay, because H over H, anything over itself is equal to 1, so it's essentially gone. Just remember, if you do it to one side, you got to do it to the other side. All right, so let's just update this problem. We got A over H is equal to 1/2 B. All right, now, so we have 1/2 times B. So how do I get rid of this half, right? If it's multiplication, we need to divide. But dividing fractions, we really just multiply by the reciprocal. And the reciprocal is 2 over 1. And so these would cancel, and you would just be left with B on this side. And remember, if you do something on one side, you got to do it to the other side. So we got to multiply this side by 2 over 1. So in the end, this is just going to equal 2 times A. It's not an A. 2 times A, I should write this capital. 2 times A over H is equal to B. All right, let's keep going here. It's number 6. I need to isolate R, and that's only one R. Okay, so let's see. First thing, let's get rid of pi, divide it by pi. Right? Anything over itself. Divide this by pi. Pi over pi equals 1, just like everything else. So now I'm left with A divided by pi is equal to R squared. Okay, remember this is inverse operations, right? The opposite of squaring something is taking the square root. So if I take the square root of R squared, I'm left with R. If I do it to one side, you got to do it to the other side. So I can just leave that just like this. The square root of A divided by pi is equal to radius. Okay? All right, let's keep going here. I'm going to zoom in a little bit more so I have some more room. Okay, here is an instance to show really why it's important to work in reverse GEMDAS order, right? If we were solving this, we would have to work inside these parentheses or these grouping symbols first. But we're going to do that last this time, right? We're going to go in opposite order. So first thing I want to do is divide by H. Divide by H, it's gone. Divide by H, right? If I do it on one side, I got to do it to the other side. Now if I want to get rid of this half, I'm going to multiply by 2, right? 2 over 1, that's going to cancel, so that's essentially gone. If I do it to one side, I got to do it to the other, so I'm going to multiply this side by 2 over 1. All right, so now I'm really left with 2 times A over H is equal to B minus 1 plus B, or not B minus 1, B1 plus B2. All right, so now I want to isolate B1, so now I just want to subtract B2 and subtract B2. Now how do we do this? This is actually just one term, and this is going to be separate. So all we have to do here is just write these separately and just do 2A over H minus B2 is equal to B1. That's not so bad. All right, let's keep going. Number 8. Here's an easy one. All right, this is just the formula for calculating simple interest. So we just have, so interest is equal to the principal times rate times time. And we want to isolate the R, or the rate. And so this is just P times R times T. So all we have to do here is divide by P and divide by T, and these will cancel. And if you do it to one side, you got to do it to the other side. So we just are left with I over PT is equal to R. Super easy. All right, how about this? We got slope-intercept form here. You know, usually we solve for y, but let's see, can we solve for b? All we have to do is just undo this operation here. And this one's a little tricky because you might think, oh, well, we're multiplying, right? But really, we're just adding m times x plus b. So really, all we have to do here is subtract mx, and they'll go away. And now, if you do it to one side, got to do it to the other side. Just keep in mind these are attached over here because this is m times x. But we're not just going to write this as one thing. We're going to write it as y minus mx is equal to b. All right. Number 10 looks like the formula to convert Celsius to Fahrenheit. So let's see. First thing we want to do is get rid of this 9/5. And remember, so multiplying a fraction, right, we would be doing 9/5 times c. So we're going to divide, which is really just multiplying the reciprocal of 5/9. This all cancels out. And so if I do it to one side, you got to do it to the other side. So now I'm left with 5/9 f is equal to c plus 32. And now I just need to subtract 32. Subtract 32. Obviously, these are not like terms. We got 5/9 f minus 32 is equal to c. All right. All right, few more here. Number 11. Oops. All right, so we want to get that r out of the denominator. Anytime you have something in the denominator that you want to give out, you just got to multiply by that. So we're going to multiply by r, cancel it out. If I do it to one side, got to do it to the other side. So I'm going to multiply by r here. And now I'm left with x plus z minus w is equal to 1 times r. So we can just put r there. And now I need to isolate z. Okay, so I need to subtract x and add a w. And so that's all I got to do on this side too, right? Minus x plus w. We can rewrite this here. I get z is equal to r minus x plus w. And that's it. I've isolated z. All right, last one for today. I only got a minute and a half. I'll try to be quick here. I got to isolate y. So first thing I want to do is get rid of that 2. Multiply by 2, it cancels out. So now I'm left with x plus y is equal to 2a, right? I multiply by 2 on both sides. Do it to one side, got to do it to the other. And now I just need to get rid of this x. So I subtract x over here. Do it to one side, got to do it to the other. I'm left with y is equal to 2a minus x. All right, I think that's all we'll get to today. Why don't you guys give some of these practice problems a shot? You guys should be able to do, I don't know, at least 10 of these today. So give that a shot. Let me know if you need help. Good luck.